So this one is a true or false question, or set of questions that I kind of like. And I hope you're listening to this because it's nice to talk about these things a little bit. So problem A says, so if it's true or false, state it. If it's false, give a counterexample. And those can be very detailed or very simple, but the idea here is we'll go through them. We'll go through each one. And so the first one is, because it is not a contact force, gravity cannot do work on an object. And that's false. Right, so that's an interesting one, though, but because I can see where people might think that. But essentially, any object that's falling is getting pulled down by gravity, and so gravity is doing work on that object. If you want to flip it and say that it has potential energy based on its height, that's fine too, but essentially, as it falls, let's put it simply, any falling object is experiencing work by gravity. So it doesn't have to be a contact force. Now, static friction is unable to do work on an object. That one, at first glance, that seems like it's going to be true. And I can see why somebody would do that, absolutely. But if you're a runner, you realize that static friction is what propels you forward. So you plant your foot, and your foot is not supposed to slide. Sometimes it does a little bit. Had one marathon where I fell down 8 times. That was terrible. Because I went back in the woods and stuff, and running across rocks and things. It was terrible. And so you're not supposed to. Your foot's not supposed to move. You plant your foot and you push forward, and that's static friction taking over, and but your center of mass is moving forward while your foot is planted on the ground. So you have to be a little bit careful. If your system is your body, then the static friction is actually moving you forward, is actually doing work. So running, or runners, right, use static friction to move forward. And then the last one is, if a particle moves along a circular path, there is no work being done on it. That one seems quite reasonable, but that one is also false. So the idea with the circular path thing is that you've got a particle and it's moving like this. Oops, not quite like that. And you've got like a rope that's holding it in, but the idea is that the rope is always pulling perpendicular to the path, so you might look at that and say, well, there's no work being done. And that's not quite true. If it's moving at a constant speed, that'll be true, but it doesn't have to be. This thing could be accelerating in this direction, in which case theta double dot is not 0, and then there could be work being done on it. So that was good. That was a good problem. Those are good questions to ask, good things to talk about. I feel like we really learned something here together. That's good stuff.